Very quick video here. I wanted to give you guys just a quick overview of how to throw together some of the Fusion 360 parts that I'm having you make. One important point here, I'm going to go quickly on the video because you can always pause it and go backwards. So if you go into your class and you go to your classwork in Google Classroom, you can see I have 1, 2, 3, 4, 5, 6 different parts I want you to make. And then once we get those made, then we'll use this video to put them together. We made the base together in class. I already gave you a video and made the assignment for you to make the bracket. The next thing we're going to make is going to be, let's see, I'm going to do the hex nut next, and then the clevis, then the hex bolt. The bushing, I'm going to leave that to you to do on your own. In fact, I may have to leave a class earlier than usual, and if I do, I'll leave you guys to make the bushing, which literally is like a 5-minute part. It's so easy to make, especially if you've done the others, so it shouldn't be an issue at all. So I think what we're going to do now is the hex nut. So let's take a look at that real quick. And there are handouts I've given you there for that. But if you look at this hex nut, it's real simple. You're going to make a hexagon on the top surface whose center is on the origin. We haven't made a hexagon before, but I'll show you how to do that. Then you'll create a sketch with just a single point in it directly over the origin. Then you'll use the hole feature, and we'll make a hole with this specific designation here, 3816 UNC. Then when we're done with that, we'll fillet all the faces at 0.020. So pretty straightforward. Let's get started here. So you're going to start off by making a sketch on the top plane. You're going to create a polygon, and it automatically creates a hexagon. You want to, if you're first clicking the center like you were doing a circle, kind of draw up into the side a little bit, and click again. We want this to be oriented so that that top edge is horizontal. So I first have to hit escape to turn off that tool. And then I go in up here to the constraints. Actually, before I do that, I'm going to grab one corner here and rotate this around so it's almost horizontal anyway at the top. And then I'm going to apply it. The reason we do that, as you remember, is that if it's nearly vertical and you apply this, it'll make it vertical instead of horizontal. So we want that top edge there to be horizontal, so I get it nearly horizontal, turn on horizontal vertical constraint. And then, I have to hit escape here because that point was already selected. So horizontal, vertical, and come down and hit that line right there. And the little glyph there tells you it's now horizontal. You can't rotate it anymore. Next, what we do is we take a look at our drawing here, and it says that it is 0.5625 from the bottom edge to the top edge. So we go into here, and Smart Dimension, oops, messed up. Let me click solid there. Oh, it left the sketch? No. What happened to my sketch tools? Oh, that's irritating. All right. I made a little mistake. I actually accidentally clicked mesh up here instead. It changed my menu, but look here, there it is. There's sketch. So I'm not going to have to leave my sketch. I can go right here. Go back to sketch. There's my sketch tools. Okay, sketch dimension. Hopefully that didn't happen to you. I click that. I click that. I come over here. And what was that number now? All of that I forgot. 0.5625 right there. Let's go back in here. 0.5625. Hit enter. And finish that sketch. Okay, now we want to, sorry, I'm just going to quickly look at this. That's irritating. Why is that like that? Oh well, I guess I won't bother with that. Let's go here. We're going to extrude it 0.3281. Let me go into here. Oh, now it's, let me click home. There we go. We want to extrude this new body distance of 0.3281. And I say, okay. I click this again so I can see it in a normal size. Now we're going to make a sketch on the top surface. It's simply a point on the origin. The simplest sketch we could possibly make. Finish that sketch. Then we'll use the hole tool. We'll always, don't ever do the single point, even though this is a single point. Always do the from sketch. Because what that does is it links the feature and the sketch together. So we'll do that. I'm going to click that button right there. Now, this is new, so I'm going to go through some of this stuff. We've done the Hole Wizard twice before on the base and on the yellow bracket. But now we're going to do something different. The base and yellow bracket, we just literally gave it a 0.5 inch diameter. This time we're doing a very special kind of hole. The first thing, of course, is easy. Right here, the extent, we just want this to go through everything, so through all, that's easy. The hole type, this time, we do not want it to have a counterbore or a countersink, as these pictures indicate, but we do want it to be tapped. Tapped means it's got threads cut in it for a bolt to go through. So we're going to choose tapped. And we do that, you can see the dialog box alters a bit. One thing it gives you is thread offset, and make sure you did not click taper tapped. You want plain tapped. If you click taper tapped, just go back and click regular tapped so you can get this right. But we do not need an offset. We do want the threads to go fully through, so we'll leave it on full. And then down here, this is the big thing here, and this is why the hole wizard, the whole feature is so good, because it has built into it all the standard nuts and bolts and screws that exist. And so the first thing you have to do is you have to choose which class of engineering standards we're going to use. In our case, for this, and this is what we use thoroughly in this class, is the ANSI or ANSI Unified Screw Threads, American National Standards Institute Unified Screw Threads. So that's what we want, ANSI Unified Screw Threads. Then under designation, if we look here, it says it's 38-16 UNC 3B. 3816 UNC 3B. So let's go to here, click this down arrow. Oops, not that one. Sorry, here. Click this first. 3/8 of an inch is 0.375. So we're going to choose 0.375. And look, it automatically picked, for me at least, 3816 UNC. But if it doesn't do that, you can look at all the other 3/8 options here. UNC stands for Unified Normal or National, I forget. But C is coarse threads. The only other ones you're likely to ever encounter in your life is 3/824 UNF, which is fine threads, but we want the UNC, so we select that. And then another thing is you can have threads that are very tight to the bolt, you can have threads that are loose from the bolt, and you can have threads with a normal fit. And they're designated 1, 2, and 3. You can also have threads that are left-hand threads, which has to do with the B here, B or A, I believe, are the two options. So what we want, though, is we want 3B, and that's a right-hand thread. If you change it to left-hand threads, then I think this, it still does 3B, okay, but you want right-hand threads. So anyway, bottom line, ANSI Unified Screw Threads, change this to 0.375, check this is 3816 UNC, this is 3B, and that's right-hand. Only last thing I need to talk about is modeled versus not modeled. The deal here is right now, this is kind of giving me something that looks sort of like threads in there. It takes a whole lot more computing power to actually draw them as if they were really cut into there, a little more detailed drawing there. I usually leave this off because that's good enough to let me know it's a threaded hole. I don't actually need to see it precisely like it should be. But modeled is an option you can activate or not, as the case may be. Anyway, I leave it off. Say okay. We're almost done with this, believe it or not. It's a very simple part. All that's left to do is we want to do fillets. And in this case, the fillets we're going to do is every face. And if you click a face, it actually selects all the edges of the face. So that top face, let's flip it over here. Select the bottom face. Let's collect the three sides we can see looking at us, and then turn it completely over to the other side and click the three sides that were opposite us. That's all the sides. Now, the dimension we want on that, if you go over here and check, it says fillet all faces and edges at 0.020. So let's go into here and put in 0.02 and say OK. And you can see it rounded off all those edges. It even rounded off, this is kind of interesting, down inside of the hole here, this edge here, it rounded that down. And that actually is pretty common. Usually it's a chamfer rather than a fillet on real bolts and nuts. But when you make a threaded hole, it actually, real ones, they often will give you a little bit of a taper leading into the threads. It makes it easier to align the nut and the bolt when you put them together. Last thing we want to do is we want to change the material. Now, before, when we went into modify, you change the appearance. We do want to change the physical material, but what I discovered is that they've Fusion, for reasons I cannot fathom, have made this really complicated. So the better way to change the physical material is come over here to this in your browser over here. And if yours is minimized like that, just click that to maximize it. Under the browser, the first item here that currently says unsaved, right click on that. Right click, not regular click, right click on that. And physical material there comes up. And it's much easier to use this physical material. Wait, there it is. This physical material. It takes a moment to come up. Dialog box than the other one. Okay. Now, this one, I already have steel installed, but if this is empty up here, or if what's here isn't steel, then what you need to do is make sure this is Fusion Material Library, and selected there, okay? And then come down here and under Metal, you can scroll down, it's alphabetized, which is a little irritating because stainless steel comes before regular steel, which is a little silly. But right at the end of the stainless steels, there's plain steel here. So if you don't have it here, click it and drag it up to here. When you drop it in place, and it says it couldn't be added because it's already there, then click it and drag it onto your material and say close. That doesn't seem to do much. It still looks the same. That might be for me because I already had steel as my only material anyway. But what it really does is later on, if you get more advanced into this engineering stuff, you're going to find that there are times you need to know the exact mass of something, or you're going to need to know its rotational inertia, or its center of mass, or all these kinds of things. And if you give it the appropriate material, this software actually has the capability of calculating all of that stuff for you. It'll calculate the exact volume and all of that. So that's why you might want to know how to go in and change the physical material of an object. So we need to save this. This is important. In class, I'm going to make sure you make a folder called Learning Assemblies. So I'm not going to go over that right now, but I do want you, when you go to save it, you click Save. Make sure that you click this down arrow and select Learning Assemblies for you to store it in. We have different places. I've already done the Hex Nut, so I'm not going to do it, but you'll click Learning Assemblies. So it says Learning Assemblies here. You can restore that if you want, or you can leave it like that. And then here we want to call this Hex Nut. So you call it H-E-X-N-U-T, and then you'll click Save. I'm not going to click Save because I don't need to save it. I'll just click Cancel. So that's the Hex Nut. I'm going to stop this video, and then I'm going to make the next video for the next part.